everyone. We're waiting for here the title. It's much shorter here than in the abstract. It was a very long one. So I'm Jordi Deu-Pons. I'm from Seqera Labs. Seqera Labs is the company of the creators of Nextflow workflow manager system. And here I'm going to present this Fusion file system that we released it last October. And because it's very nice to always start with a quote, and now it's cool to talk about ChatGPT, so I decided to ask ChatGPT to create a quote for me about Fusion file system. And he ended up about this thing of colossal files and moving elephants. I like this part because in some way, Fusion it's about moving elephants. So, okay, it's moving elephants, but because we are all technical, let me explain what it's in very simple way, what is the Fusion file system. Fusion file system is just a fuse file system that the very important thing is that it runs inside the container next to the process that has to use it, and it's using the local disk as a cache. So as a cache to store intermediate chunks of the files that it's using when it's reading, writing. And another important feature is that it's very tightly integrated with Nextflow. So each process that runs Nextflow, it will come with his own Fusion file system inside the container. And because it's not a remote file system, no, it's just in the container, it's using another remote data storage to store really the data. So the data storage that we currently support, the one when we released in October, it was only the S3. Then we added the Google storage, and this week we have released the Azure storage. So, okay, now you can think, well, a fuse file system, block storage, all of these block storage, they have their own Fuse client to access them. So what is different of Fusion? No? What makes it different? So let's talk about this different, what makes Fusion different. So first, this important point that it's mounted inside the container and with the process that it's going to use it. That's a very important point. We also can mount inside the container in rootless containers, in Docker, Podman, Singularity, Uptimer, all of these container systems. Another second point is because we are running in the container, we don't want to use the memory of the process, and we try to minimize the memory that we use, but then we need to use local disk as a cache for the files. And then the most important thing, this concept, because there was no concept similar, we decided to put this name, intra-session consistency. What means this? So many times, for example, when you talk about S3, you have the concept of read after write consistency. So that means that S3 only guarantees you that when you have finished writing a file, the next read that comes will be able to read that file. So it's, for example, the consistency of S3. In this case, what we do, intra-session consistency means that we only guarantee a session it's when the container starts, we mount the full file system, and when the container ends, we unmount it. So this is a session. So what we guarantee, the consistency, is that the process will be able to read any file that was there when the session started, but not the things that may have appeared in the middle. And we guarantee also that when the process writes a file, that file will be on the remote storage. We only guarantee at the end of the session, when we shut down the container. This is very important. Why? Because this gives us a lot of very interesting things that we can do. We can do because we are running tied to Nextflow, and Nextflow knows which are the input files of that process. We can do some kind of predictive download. So in advance, before the process will need that files, we can start in background downloading the first chunks of that file. So they will be ready local for when the process needs them. Also, we can do the same with the writings. We don't need to have we don't block for the write. So that means that the process can write, and as soon as the write file is in the local cache, it can continue. We don't block. We don't have to block until the file is fully uploaded to the remote data storage. because we only guarantee this intra-session consistency. So at the end, what this means is that we are decoupling the process from the data transfer to the remote data storage. And this is very interesting because Fusion can try to use the bandwidth that we have with the data storage in a more efficient way than the way that it's doing the process itself, that in general are this kind of heterogeneous bioinformatic tools that they do strange things sometimes. So, but we can put in the middle Fusion to optimize this traffic. So, okay, why we develop Fusion? What were the main reasons? We begin thinking in this because we have many customers and users running Nextflow in cloud, Amazon Batch, and other Google Batch and the Azure. And we have many problems. Because most of the problems is because Nextflow, it's a workflow manager widely used for pipelines that they use big files. So they need to read and write and move big files. And this, with the cloud, it's a problem because you need to give them, for example, the first problem. If we use Nextflow in the most simple way, what needs to do Nextflow is when you start the process, it needs to first download all the inputs to the local disk, process them, and at the end upload. This means that you need to wait a lot of this staging time. You have wasteless. You are paying for CPU time when you are not using at the beginning and the end, and you are paying for that CPU time in the cloud. So we wanted to remove these staging times. Another thing is that in the cloud, if you still need to provide a local disk, that's a network disk, EBS, for example, we have a problem. We don't know how much storage that process is going to need locally. So, or you allocate a very big one disk, like it's the case when you are use FSX Lustre file system as an ephemeral file system, you allocate more than what you need. Or for example, what we do with CBS, we need to auto-scale. We have an auto-scaling that it's scaling the volume as soon as we detect that it's needed more space locally. Another alternative that it's for performance is not very good, it's EFS, that it's a network file system, but at least in EFS you don't need to worry about the size of the disk. So we wanted to simplify this infrastructure deployment and to just remove all this. So we don't want to use it. We just wanted to use S3 that is cheap, it's fast, and it's scaling infinitely. So you don't need to worry about how much storage are you using, at least when you are running. Of course, after the run, you have to be worried if you are generating lots of teras. So also what we wanted is, I will say that at the beginning, we wanted to get some solution similar to what you get with FSX Lustre, in some way to try to take advantage of that S3 is fast and the local NVM disks are fast. And at the end, of course, all this was to reduce the cost when you run a pipeline, a big pipeline with Nextflow in the cloud. But then, have told you that Fusion is also working with Singularity, Uptimer, Rootless, and Nextflow is also widely used in HPC centers. What we want is to also bring the benefits of Nextflow in HPC. So first thing is, main reason is for usability. We want to bring to the user the same experience where they run in the HPC center and when they run to the cloud. The same experience in terms of data, because to move the compute is really well solved for many workflow manager systems. But when you have these big files, it's not that easy. It's not that easy that you are in your HPC center and now you want to launch things in the cloud. The pain point is this moving data. One thing that we think that Fusion can also bring to the HPC, this is some of these points is things that we are working on because for us is the next step of Fusion. It's to try to remove the storage pressure. So because we are decoupling the data transfer to the storage system from the process running, we want to try to optimize the way that the data is transferred to this shared file system, or even in an HPC center, you can use a block storage for this kind of runs, so it will be perfectly possible. And also, in some cases, to get the same for this kind of pipelines, to get performance similar to the ones that you can get with FSX, Lustre, or other parallel file system, but without that complexity, because maybe you want to store this big data in a block storage if you are a very big data center, or if you are a very small data center because you only have a network file system with only one server, so that's not scaling so well, and you have more problems with a small file. No, with Fusion, it's you doing less transfers. It's minimizing, and at the end also to try to simplify infrastructure. So okay, let's see some numbers. This is a benchmark that we did before releasing on October. And it's because I told you that the first use case for us was to improve this cloud experience and to reduce costs. This is a normal run of an NF Core RNA-seq pipeline, with a standard file. So it can be something. It's not. We have customers that they are doing much bigger analysis, but mainly they are more like that they have more samples, but not bigger than this. It just the dimension is more on the number of samples. So it's a quite good test for what we wanted to improve. So and here we are comparing for ways of deploying this in this case to Amazon. The first is just using S3. So it's this case that we first need to download each process of Nextflow. First needs to download from S3 to the local, run, and at the end upload. So of course, this has the problem of these 200 hours in the staging. So these are 200 hours that all the processes in this pipeline have been only downloading or uploading files. So it's a waste of time because in general, this process, they need big instances with lots of CPUs. You are paying for all of them and you are not using the CPUs, and you are paying and you are blocked because you are doing the transfer. So, and the second option, it's using FSX for Lustre, but with a local scratch. So that means that still we are mounting the EBS disk as a local, an auto-scale EBS disk. We are creating an ephemeral Lustre file system with the problem that you have to decide the size in advance. We run, so that means that the process, they will run. They will read the files from the Lustre file system. They will write to the local EBS. Well, not local, but local in terms of instance. And at the end, the files will be copied back to the Lustre file system. This is a quite typical way of deploying in Amazon Batch. And the other one that we wanted to test to be more similar to what we are doing with Fusion is also with a FSX for Lustre file system, but without using the local disk. So that means that the process is directly writing to the Fuse Lustre file system. So there is, as you can see here, what is very good of here, I don't see my pointer, but if you go to the staging hours, it's nearly 0.42. So this was expected, no? Because the Lustre file system, it guarantees the consistency immediately. So when you finish to write, it's already in the file system. So you don't need to have you don't have a staging time, neither reading or writing. And at the end, the Fusion, it's a all of these runs, they were run only using on-demand instances to avoid having spot interruptions and to be able to compare the timings of the pipeline. And also all of them using the same kind of instances with the same families of CPUs to be able that the improvement of the results was coming from the file system and not from the input-output and not from the CPU. So what is the setup? The setup is just running Fusion files, mounting Fusion file system that it's directly interacting with the S3, so it's reading directly from S3, and the process is also writing directly to the Fusion file system, so that means that there is this local cache, but at some point it will be copied to the S3. And at the end, when you shut down, that's important that Fusion file system, it's not, what we store, what you see in the S3 after running with Fusion are normal files. So it's not like a huge file system that they have their own format of data and it's very good performance on top of S3, but then you don't, the files that you have are only accessible with, you need to mount JICE, I don't know how to pronounce, JICE-FS. In the case of Fusion, you have normal access to the files. It's not a special. You don't need Fusion to access that files after using them. And we can see, even to be honest, it was not expected. We were only wanting to be similar in terms, something similar to the performance of Lustre, but it ended up that it was faster, a bit faster. I wouldn't say that it's the important thing. The much important thing is that all the simplification of all your deployment and infrastructure. But at the end, even if we didn't expect the performance to be much better than FSX Lustre, we really expected that the price was much better because we are using only S3. We don't need to pay for EBS disk. We don't need to pay for Lustre. To access S3 in the region, you don't have intra-zonal cost, things like this. So the cost is really, really different. It's the cost. In the first column, we have the cost of just running when you run. And in the second column, we are like, what we show here is the cost of storing the data produced by that run during 1 month. Why we also added this? Because it's also very important to understand that nobody is using Lustre and keeping the things in the Lustre file system. So immediately when they finish the run, they copy to the S3 storage, and they remove, or even they do this ephemeral FSX and they shut down the Lustre file system in Amazon. So this is also another important thing. Here we are not computing the extra cost that you have if you use Lustre in Amazon to then copy the things back to the S3. So, okay. So more or less, this is what I wanted to show, but also because, as I had told you, we released this on October, only with S3 support. Then after, at the end of the year, more or less, was Google storage. And then this last Monday, this week, the Azure storage was released. So we have been running this in production, our customers, mainly for Amazon. Now we have some traction with Google Batch, and also I expect some traction with Azure, with our customers that use Azure. But now we want to focus more in moving to improve the things also in HPC. So we are starting from a good point, that is that Fusion file system can run in a rootless container. So that's a very good point, because that means that we can run with things like uptime, singularity. But still, we need to improve many things. We need to make, because Fusion file system, it's a universal file system. So you get a universal path, and you can access, even you can run in your laptop and transparently access Amazon S3. But it's running and it's taking care also this remote access. So we want to be able to move this to also help moving data from the HPC to your storage in the HPC to the cluster and the other way around in a transparent way. Also, in terms of I think that we have a lot of lots of things that we can improve in terms of performance. That one is the first, it's to improve the garbage collector, the cache garbage collector that we have. Right now it's very simple. So the garbage collector is the one that has to decide what I remove from the cache because it's already uploaded and it's not going to be used again, these kind of things. I think that we can improve it a lot because for now, for example, to run these RNA-seq pipelines that they produce, I think it's few teras of data, the whole run. We are using a cache per instance of, with 100 gigas it works well, even with less, but 100 gigas. We want to be able to run this kind of pipelines with even less local cache, not for running with less, but because we think that we are going to run with bigger files. So we want to be prepared for bigger files. And then another thing, we can collect metrics of input-output, because the thing that we are next to the process that we are running, it gives us a lot of visibility to collect metrics and then to say, okay, this process in the pipeline, it's consuming a lot of input-output, CPU, memory, and it will be very nice because you will get these metrics, but very related in the context of your pipeline. So that will be very interesting. We can do things like transparently compress the files that we know that are intermediate files, and at the end of the whole run of the pipeline, we are not going to need, so we can compress all these files on the fly. Another interesting thing, augmented security. What's this? So we are in a container, it's secure, it has the limits, but then when that process can access to anything that the user has access in the data storage. What we want to do, because we are running in the context of a pipeline and we know which are the inputs of that process, we want to allow that process only access the files that it's declaring in the pipeline that it's going to use, and only write to the folder that has to use write to the outputs. Even we can cut down the network for only that process, so he can only interact to the wall with the file system. So it's an extra security. It's at the level that you don't need to trust the developer of that specific tool in your pipeline, because you know that tool that you are using in your pipeline, it's going to only be able to access what exactly you are declaring in the pipeline. So I think that it's also a very interesting concept that we can do. Also, we want to make this, it's agnostic in terms of what storage you can use in the backend. So right now we mainly have been implementing block storage, but why not we can use other kind of storage as a backend. So and with this, thank you. That's all.
Thanks.
We have a question from Slack. What are the performance and stability implications on implementing this file system as a user space fuse module?
Expected question. Okay, good question. What are the implications? So the support for Fuse in the kernel has really improved a lot since many years ago. But apart from this, the main problem is of latency. So you have to do this context switch between user space, kernel space. So this, of course, this add and will always add a bit of latency if you compare with a kernel model that you can develop something similar in a kernel model. But our use case, it's big files. And what we are worried, and what is about throughput, it's not a problem For the throughput, it's not a problem, Fuse. The only problem may arise in latency. But for these kinds of pipeline that it's Nextflow with synchronizing the process, we don't care about latency. They are very big files. We do this so we decouple the process from the data transfer. So in general, this is not a problem. I mean, of course, it's not the same. I'm not meaning that this is this can work for any kind of workload. No, this is for this kind of load that they are doing a lot of input-output of moving big files, reading and writing. It gives a lot of benefits.
And a second question for the same person. How do you manage data safety on local cache for each container?
Well, it's the file system of the container, so only that container can access.
Okay, there is any other question?
Hi, so I have a couple of doubts about the cost model that you presented or the analysis. I was a bit surprised to see that the number of billable CPU hours was going down, but the price was going up, especially on the case of the FSX.
Yeah. Okay. Yeah. FSX, it's really expensive in Amazon. So that's the answer. So even you can see that you can say, okay, we are going from this nearly $100 with only S3, that it uses 200 more of CPU hours, to the more or less the same price with Lustre. This is the cost of the Lustre file system. Also, it's the cost of that you pay for that time of the Lustre file system. Also, Lustre file system has the problem that still you need to download the things from S3 to the Lustre file system, and also has another problem that this kind of the usage that the Lustre file system, it's only in one zone of the region of Amazon. So you are also paying for intra-zone cost. And this was made on purpose, this kind of use, because it's the normal one that we see in our customers. Yeah. They need to use the whole region.
Okay. So the compute column here doesn't only reflect compute cost, it also reflects the storage for the...
It's what you pay for running that. Yeah. Also, it also includes the EBS cost. That it's not that important, but still it's there.
Okay. And I have another question. How does Fusion cope with using preemptible instances like spot instances? So if your process is killed or your instance is terminated, how does Fusion cope with that? Are you gonna lose whatever you've written until then because you're between the session, you've not finished the session, so?
Yes, but you are going to lose what the process has written. But this happens also with the other, because in general, this kind of pipelines, we cannot resume. We can resume at the level of each task, but we have to repeat the task also with the other file system. So we rerun the task. Fusion also detects that and also remove if there was any partial file, but we cannot, because we don't control the exact tool that is running in that task. We cannot do it in any other way, but not for Fusion, also for the rest of file system.
There are more questions, but we need to stop here and to proceed with the program. We are going to have lots of room for ongoing discussion. Okay. Thank you so much.